Okay, so this is our video on volumes of revolution and known cross sections. Um, let's start with number one. All right, best idea in these things is always to draw the picture. So number one tells me I'm in the first quadrant. I have the secant. Well, the secant has an asymptote at pi over 2. It starts at 1 and goes up. Remember, it's the same as 1 over the cosine. So if you're going to think about that, it'll work a bit there. We only care for this thing going to pi over 4, and then we're going to use the axes as boundaries. So this is the piece that we're rotating. We're rotating it around the x-axis. So we can do this pretty straightforward. We go volume is pi times the integral 0 to pi over 4 of the secant, and I'm going to square that, of x. The antiderivative of the secant is the tangent of x. So that's from 0 to pi over 4. So this is going to be pi times the tangent of pi over 4 minus the tangent of 0, which is going to be pi times 1 minus 0, which is pi. So that answer should be C. All right, so that wasn't so bad. All right, again, number 2 here. Let's start with the drawing. Okay, so we have the region enclosed by the graph of y equals x squared. Okay, so that's just your regular like parabola here. Y equals x squared. And then we have the line y is, sorry, not y, x is equal to 2, right? And the x-axis, so that's this space. And we're going to revolve this around the y-axis. Okay, so that's a little different, right? We're going in a circle here, and we're going to a little circle there. So like this is like kind of a dish maybe, or a bowl with a flat bottom that a piece has been hollowed out of the middle. All right, so the best thing to do here is to consider this as a derivative with respect to y. So this is going to be pi, and then we got our bounds of integration. So the lower bound is going to be 0 here. And if I think about this, this is where the upper bound happens of this thing. So the y here is going to be 2 squared, which is 4. So the bounds of integration are going from 0 to 4. Okay, so the outside radius is just 2. The inside radius is, okay, so we have y is equal to x squared, which means that x is equal to the square root of y. So this is going to be minus the square root of y squared dy. Okay, so this is pi times the integral from 0 to 2 of 4 minus y dy, which is pi times, let's see, that's going to be 4y minus 1/2 y squared from 0 to 2, which is pi times 16 minus, let's see, 16 over 2 is 8. And then both of these are 0. So 16 minus 8 is 8 pi, which is, in this problem, letter A. All right, so that one's a little tricky because it's going around the y-axis, and it's got a hollowed out center, and all kinds of crazy things that you got to think about there. But in the end, we got it. Okay, so in this problem, we are e to the negative x, which goes like this. And we have the two axes, and we have the line x equals 3. So the region that we're bounding there is this. Now, we're talking about cross sections, which are squares, right? So each square is perpendicular to the x-axis, making a cross section. The length of that square is determined by its x value. So that means the length of every side of that square is e to the negative x. So the area of that square is going to be the length of that side squared, so e to the negative 2x. So volume is going to be an accumulation of those squares from 0 to 3, right? So this is 0 to 3, e to the negative 2x dx. The antiderivative of e to the negative 2x is going to be negative 1/2 e to the negative 2x, and that's from 0 to 3. So this is negative 1/2 e to the negative 6 minus e to the 0. E to the 0 is 1, so that's going to be e to the negative 6 minus 1 negative 1/2, which is the same as 1 minus e to the negative 6 over 2, which gets me letter A. Alright, so there you go. That's problem number 3. Alright, 4 is a little tricky. We've got an ellipse here. That's x squared plus 9y squared is equal to 9. If I divide that through by 9, I get x squared over 9 plus y squared over 1 is equal to 1. That gives me the picture of what this ellipse is going to look like, right? Because this 9 is the major axis, so that's going to be 3 in every direction from the center. This one is the minor axis, so that gives me this shape. And according to this problem, I'm taking that shape and I'm revolving it around the x-axis. So I'm going to get like this egg. So really what I need to know is what this curve is, right? Because this curve is going to run from negative 3 to 3. So let's see. If I have x squared plus 9y squared is equal to 9, then 9y squared is equal to 9 minus x squared. Y squared is equal to 1 minus 1/9 x squared. Y is equal to the square root of 1 minus 1/9 x squared. Alright, so, and I only need the positive version of this, right? Because technically that's plus or minus, but I only need the positive version because I need the top of the curve. So my volume will be pi times the integral from negative 3 to 3 of the square root of 1 minus 1/9 x squared dx, which is pi times negative 3 to 3 of 1 minus 1/9 x squared dx. Yeah, so let's take the antiderivative there. I get pi is, it's pi times x minus 1/27 x cubed from negative 3 to 3. So let's draw a little line here because that's going to be pi times, let's say that's going to be 3 minus 1, right? Because that's going to give me 27 over 27, which is 1, minus negative 3 plus 1, right? So that's pi times 2 plus 2, which is 4 pi. That should be letter B. Alright, so lots going on there, non-functional stuff, ellipsoid type things, but we can do it. Okay, so let's look at number 5. The base of the solid is a region in the first quadrant, enclosed by the parabola 4x squared, so that's just like this, 4x squared. The line x equals 1, there we go. And each plane, so everything that's perpendicular to the x-axis, so that's this, is a square. So again, we got squares here, right? So the length of one side of that square is going to be 4x squared. We are going to find the area of each of those squares, so I got to square that. That gives me 16x to the 4th. So the volume is going to be the accumulation of those from 0 to 1 of 16x to the 4th dx. So that's going to be 16 over 5x to the 5th from 0 to 1, which is 16 over 5 times 1 minus 0, which is just 16 over 5. And that guy is letter D. All right, so there you go. So looking at number 6, we're in the first quadrant. We are enclosed by x equals 0, y equals 5, and the graph of x squared plus 1. So that's this guy, right? And then we are going to rotate that around the y-axis. Right, so we're going to get like a round bowl here, right, when we do that. So this is going from 1 to 5, right? So volume here is going to be the integral from 1 to 5. Now, I know that y is equal to x squared plus 1, which means x squared is equal to y minus 1, which means x is plus or minus the square root of y minus 1. We only need the positive one here. This is going to be pi times the square root of y minus 1 squared dy, right? So this is going to give me pi times integral from 1 to 5 of y minus 1 dy, which is pi times 1/2 y squared minus y from 1 to 5, which is pi times, let's see, that's going to be 25 over 2 minus 5 minus 1/2 minus 1. Alright, so that's pi 25 over 2 minus 1/2 is 24 over 2. Negative 5 plus 1 is negative 4. So that's, let's see, 12 minus 4, which is 8 pi. So that one is B. All right, let's keep going. Okay, let's look at number 7. All right, let's see. I have the graphs of y equals 1. So that's there. Y is the sine of x. So that's that guy. From 0 to pi over 2, right? So that's this. And we're going to revolve that around the x-axis, right? So I'm getting like something with a hole in the middle of it, right? Okay, so volume of this thing is going to be pi times the integral from 0 to pi over 2. The outside radius is just 1. The inside radius is formed by the sine of x. That's going to be sine of x squared dx. And that looks like D. So there you have it. That one comes out as letter D. Cool. All right, so let's look at number 8. Okay, in problem 8, we have, all right, so we've got the x-axis, we have the line x equals 3, and the curve y equals square root of x. Okay, so we're going to take this, and we're going to revolve that around the x-axis, so this is pi times the integral from 0 to 3, square root of x squared dx, pi times the integral from 0 to 3 of x dx, which is pi times 1/2 x squared from 0 to 3, pi times, let's see, that's going to be 8 over 2 minus 0. 8 over 2 is 4, so that's 4 pi. So whoops. I see where I made the mistake. Do you? 3 squared is not 8. 3 squared is 9 over 2 minus 0. So that's just going to be 9 halves pi. All right, there we go. And that's C. All right, so here we go. Catch our own mistakes here. Very good. All right, so let's see. What is the volume of the solid generated by the curve rotating about the x-axis, the region enclosed by the curve? All right, so we got this secant of x again from the lines x equals 0, so that's this, y equals 0, so that's this, and the line. All right, so remember secant has the asymptote pi over 2. It starts at 1, goes up. So pi over 3 is around here somewhere. And we're going to take this guy and we're going to revolve it around the x-axis. So volume is going to be pi times 0 to pi over 3 of the secant squared of x dx. The antiderivative of the secant squared is the tangent of x from 0 to pi over 3. So this is pi times the tangent of pi over 3 minus the tangent of 0. The tangent of pi over 3 is the square root of 3 minus 0. You can check that using your unit circle. So this is going to be root 3 pi, or pi root 3, which is C. All right, so there you go. All right, so let's talk about number 9 here. What is the volume of the solid generated by rotating about the x-axis, the region enclosed by the curve? Oh, sorry, just did that problem. Let's actually move on to number 10. All right, so the region enclosed by the y-axis, the line y equals 2. Okay, so we have the y-axis, the line y equals 2, and the curve y is equal to square root of x. So we're taking this guy and revolving that around the y-axis, right? So we're going to make like a trumpet here, right? Okay, so we're going this way. It actually goes to 0 there. All right, so this is 0, that's 2. If y is equal to the square root of x, this implies that x is equal to y squared. So we're going to take the volume as being pi times the integral from 0 to 2 of y squared squared dy, which is pi integral from 0 to 2, 0 to 2 of y to the 4th dy. So pi is times 1/5 y to the 5th from 0 to 2, which is aha. Yeah, there we have it. So 2 to the 5th is 32 over 5. This is pi times 32 over 5 minus 0, which means this is 32 pi over 5, which means that the answer is A. All right, so there you have it. That's all 10 problems. Very good. Thank you.